In this video, we're going to look at hydrates. It's important to just redefine what a hydrate is versus an anhydrous compound. A hydrate is when an ionic compound crystallizes, it incorporates some water into its structure. For example, magnesium sulfate has 7 waters that are associated with it in its structure. They are just loosely held on, so we use a dot between the magnesium sulfate and the water to denote that they're associated, but they're not actually forming covalent bonds. An anhydrous compound is one that has no water molecules incorporated into its structure. For example, you can have an anhydrous form of magnesium sulfate, and that would just be MgSO4. There are several calculations we can do with hydrates. The first example we're going to look at calculating the percentage of water in a hydrate. So we're going to look at this one given here. Now to find the percentage of water, what you want to do is find the total molar mass of the water in your hydrate and divide it by the total molar mass of your whole compound and multiply that by 100 to get a percentage. So in this one we have 5 waters associated. So we're going to take 5 times the molar mass of water. And then we're going to find the total molar mass of our entire hydrate, including those 5 waters. You should get to 48.22 grams per mole. If we multiply that by 100 then, our answer to 4 significant digits would be 36.30%. So that means 36.30% of this hydrogen is water, and the rest is this ionic compound here. Sometimes you might be asked to calculate the mass of the water in a certain mass of a hydrate. So we're going to look at 215 grams of this particular hydrate here. The best way to do this is to set up a ratio. So we know that 5 molecules of water, which is the total water, has a mass of 248.22 grams. We want to find out how much water there is in just 215 grams. So setting up this ratio will allow us to figure that out. We're going to cross multiply then and solve for x. So if you do that, because now we've got 3 sig digs in our question here, our answer should also be to 3 sig digs, giving us 78.0 grams. So in 215 grams of this hydrate, 78.0 grams of it is water. And then the rest would be made up again of this compound here. Okay, so let's look at one more example. We're going to look at a hydrate of barium chloride, which is given as the formula BaCl2 XH2O. So we don't know how many waters there are. And it has a mass of 1.500 grams. When heated to drive off the water, so all of the water is going to evaporate, the residue left is barium chloride, which has a mass of 1.279 grams. First, we want to calculate the percentage of the water in the hydrate. So, in order to do this, we need to write out an equation to see what's going on. So when you take a hydrate and you heat it up, I'm going to use delta as a symbol for heating. You're going to separate the ionic compound from the water because the water is going to evaporate and come off. And there are X molecules of water for every 1 molecule of barium chloride. Now the problem gives us a couple of masses here. It's telling us that the mass of our reactant is 1.500 grams. And the mass of our anhydrous form of barium chloride is 1.279 grams. Now we know by the law of conservation of mass that the mass of water plus the mass of the barium chloride has to equal to the mass of our reactant. So to find that, we're going to take 1.500, we're going to subtract 1.279, which gives us a mass of 0.221 grams. Now we know the mass of the water in the total mass of our hydrate. So to find the percentage of water, we're going to take the total mass of our water, which is 0.221 grams, divide it by the total mass of our hydrate, which is 1.500 grams, multiply it by 100, which gives us 14.7%. The next part asks us to calculate the formula of the hydrate, so solve for x. Now what we need to do here is we need to look at the ratio of the anhydrous barium chloride to the ratio of the water. And by looking at those ratios, it's going to tell us how many molecules of water are associated with 1 molecule of barium chloride. So we know our anhydrous barium chloride has a mass of 1.279 grams. In order to compare the number of molecules of each, we need to convert that to the number of moles. So we're going to take the number of moles is the mass divided by the molar mass of our anhydrous compound. So it's going to be 208.23 grams per mole, which gives us 6.1422, keeps going, times 10 to the negative 3 moles. We're going to do the same thing with the water. So we need to find the number of moles of water. We know we have 0.221 grams. We're going to divide that by the molar mass of water, which is 18.02 grams per mole. And that gives us 0.01266 and so on moles. Okay, so then let's look at the ratio of the two. We're always going to set it up as the moles of water over the moles of our anhydrous salt, so in this case our barium chloride. And we're just going to take our two values from above, so 0.01266 divided by 6.1422 times 10 to the minus 3, which gives us an approximate ratio of 2, or 2 to 1. You can think of it this way. That means that for every 1 molecule of barium chloride, there are 2 molecules of water associated. So this 2 is our value for x, meaning that our barium chloride hydrate has the formula BaCl2.2H2O.